was it. Not bad. 5 out of 6, 6 out of 6. Awesome. Super fast. Who is this? Good job. Okay, so I'm gonna activate this. Oh, I think I'm gonna activate it. That was decimal to So if you refresh your screen, it's going to be under class activities for Wednesday. Can you either enter the score that you got or the number right that you got? Okay, so you're going to be entering the score or the number right that you got. So just enter the score or the number you got right. Should have done this one first. Might have made it easier. All right, so this one we're converting the binary to hexadecimal. So we're pretty much doing the same thing, right? We should have done this one first. It might have made the other one easier. So we're looking at these individually, right? So 0, 1, 1, 0, that's what? 6. And then 1, 1, 0, 0, which is C, right? So you're looking at them individually in packets of 4, packages of 4. Yes, I can. Thank you. Maybe. Oh, maybe it goes on. Yeah, we should have done that one first, huh? Warm up the brain a little. Looks good, everybody. Awesome. Who's 8? Good job. Okay, so that one was binary to hexadecimal, right? Okay, so same thing there. Just go refresh. Either put your points in or your score, either one. Put your points or your score. And then also on this Nearpod, just put in there that we did it in class. Put a message that we did it in class. So when we're all done, you're gonna have the Nearpod that we did in class, and you're giving me a score on the decimal to hexadecimal and the binary to hexadecimal, okay? It's under week 2, class activities, Wednesday. Week 2, class activities, Wednesday. If you need any help finding it, let me know. It should show up in the calendar, or it'll show up on modules or your to-do list. You should see it on all 3. Okay, and then I'll take your worksheets if you would pass them to the center. Make sure your name is on it. Thank you, thank you. I'll give these back. Thank you, thank you. All right, we're gonna take a break. It is 3:30. Let's come back at 3:33. Okay, 3:33. So come back at it's 3:30, come back at 3:37. 3:33, that's not enough time. 3:37. Oh, just click on text entry. There you go. Sorry about that. For the Nearpod, click on the text entry in the middle and then just put a note in there, okay? For the Nearpod one, did you already do that one?
Oh, I was submitting my thing. I didn't have time.
Oh, okay. So if you click there, start assignment.
What is this?
This is the Nearpod that we did. Just click text entry and you put in there that we did it in class. 3:37. Hey there, do you need to come into class?
Yeah, where's the tutoring one?
So you can either work in the back row or you can go into room 107.
Okay.
There's not a tutor here today.
Oh, okay.
Normally there is, but Marcus's mom has COVID. And so to play it safe, he's staying home. Do you need help?
Yeah, with the one that's doing 6 and also here to do the labs.
Okay, the one that's, you need help with the one that we're turning in?
Yeah.
Okay. Hey, John, when you have a chance, can you help Jacob?
Is it the one that's due today?
Yeah. Well, the packet tracer and then also the lab.
Do you know when Marcus is not going to be here?
He's not going to be here today.
Oh, okay.
His mom got diagnosed with COVID yesterday,
Oh,
so
okay.
he's waiting till he tests.
Oh, yeah. All right.
Yeah. So, yeah, you can either go into 107 or just sit in the back.
Yeah, I'm in the back right now. If you go in, just when you go in, go all the way to the end.
Okay, so I want to talk about subnet masks. And after today, we'll have everything we need to be able to start doing network addressing and figuring out the network that our computers belong to. So all devices, whether it's a switch or a router, computer, server, they always need to know what network they belong to or what neighborhood they live in, more or less, okay? And so one of the ways that the devices do that is by using their IPv4 address and their subnet mask. And so again, today we're going to talk about the subnet mask, but it'll start to make more sense as we move through the modules and we move through the reading. So let's just look at our command prompt. So if you do like CMD in this search tool, and let's get into the command prompt. So you can just type CMD, and I'm in the virtual machine. So is everyone in the virtual machine? If you're not, can you get in there? Does everyone remember you click on the little Cisco lab, the little icon? Yeah. Oh, that's packet tracer. So we're looking for, so just click right here and type, just start typing CMD. There it is. So that's the command prompt. Perfect. Right? Yeah, we're going to do ipconfig. All right, so is everybody in the command prompt? Okay. So let's just do an ipconfig. An ipconfig. And I can see what my IPv4 address is, 10.204.68.203. And I can see what my subnet mask is, 255.255.254.0, and my default gateway. But what I don't see is what my network address is, what network I belong to, okay? So the computer will actually figure that out for itself. And the way that it does that is it looks at its own IPv4 address and its own subnet mask, and it can figure out the network address, which is, again, what we'll start doing next week and the week after, okay? Because every device has to know what network it belongs to. And again, I think of kind of like the network as its neighborhood or the zip code it belongs to. So like me and my next door neighbor, we belong in the same zip code, right? And here, we're all on the same network, okay? Now, I don't know, maybe the building over there next door to us, they might be on their own network, or they may be on this network too. I don't know how we have it divided up, okay? Now, the subnet mask, it looks like an IPv4 address, but it's not really an address, okay? It's really more of an indicator. Like it indicates or it tells the device, again, what neighborhood it belongs to. But we figure it out in binary just like we do anything else with ones and zeros, okay, with ones and zeros. Now the difference between a subnet mask and an IPv4 address is that all the ones will be in a row and all the zeros will be in a row. So did you see how it was like 255, 255, 254? It's always going to be like that. It's never going to be like 10, 1011, 001. It's always either going to be all the ones, and when it goes to the zeros, then it's all zeros, okay? So the ones represent what kind of bits? They're ons. And what do they represent? If you watch the video, you should know. Subnet. The net, yeah, the ones represent network bits. Okay, everyone should be writing that down. And what do the zeros represent? hosts. So in a subnet mask, the ones tell us which bits are network bits and which bits are host bits. Yeah. The zeros are host bits. Just in the subnet mask, yeah. Well, and in the IPv4 address too. So that's gonna, again, it's gonna all start to make sense. We have to figure out like the building blocks to get there. Because the IPv4 address of our device will look at its subnet mask and say, okay, wherever there's a 1 in the subnet mask, that bit is part of my network. So they work together. They work together, okay? In some ways, figuring out the binary for a subnet mask is a little bit easier, and I'll explain and show you that in a minute. So 1s are networks, 0s are hosts, okay? Oops, what am I doing? There we go. Okay, so again, if we think of a subnet mask as kind of like the indicator, right? It tells us what part of the IP address are network and what part of the IP address is the host. Okay? So the format is it's made up of all 1s and 0s, and they're all going to be consecutive. There's no flip-flopping like in a regular IPv4 address. Like a 10, I would do 0, 0, 0, 0, 1, 0, 1, 0. Right, or 160 is 10100000. But with a subnet mask, you're always going to see 1111 00000. There's never going to be flip-flopping. It's never going to be flip-flopping, okay? So we already looked and we saw that the ipconfig gives us our subnet mask. Okay, right, that's what we just looked at. Now ours was 255.255.254, or at least mine was. So this one is 255.255.255.0. So the first octet, what are all the bits? They're all 1s, and so they're all what kind of bits? Network bits. The second octet, they're all the third octet, they're all, yeah. And what about the fourth octet? All 0s. So all of those are host bits, okay? Now, the next thing that we want to start paying attention to with the subnet mask is where the last network bit is, okay? Where in the octets is the last network bit? So if I have 255.255.255.0, what octet is the very last network bit in? The third octet, right? Because if I were to write this, right, and then I've got 0s, right here is the very last network bit. And so this is my, everyone? Third octet. Third octet, right? Third octet. Okay, now what about 255.255.0.0? So where's my last network bit? Second octet. Second octet. Okay. So let's see. What if I have 255.240.0.0? What octet is the last network bit in? So 255.240.0.0. Right? So we just want to start thinking about where the last network bit is. So if I give you 255.248.0.0, how do I write 255? All 1s. How do I write 248? Yes? Right, so the 248, 0, 0, 0. So there's my first octet, second octet, and then if I write out the third octet, because in subnet masks, we know that as soon as we turn to a 0, they're all what? They're all zeros, right? Okay, so, yes, yeah, we're gonna do that next. Okay, and so what octet is my last network bit in? The second, okay, the second. Okay, so now here's the next thing we have to learn about subnet mask. So we've learned it's all ones followed by all zeros. Okay, now we are figured out we have to know where the last network bit is. The next thing we have to know is what is the positional value of the last network bit. Okay, what's the positional value of the last network bit? So what did we say about the positional values in octets? They're the same in every octet. Okay, so if we do a positional value, right? So here's one. What is, let's go from the lowest to the highest. Everyone, count with me.
1, 2, 4, 8, 16, 32, 64, 128.
Did I add an 1, 2, 4, 8, 16, 32? Okay, I have an extra one, right? Okay. So we want to know what the positional value is. So we know that this falls in the second octet. Do we agree? All right. So if I just line this octet up with my positional values, I'm going to go 1, right? Let's see. And then the rest are all what? They're all off, right? So my last network bit falls in what octet, everybody? The second octet. And here's my last network bit. What is the positional value of that network bit? 8. 8. Okay, so let's do 255, 255, 192.0. What octet am I in? Third. And where is the positional value? What? 64, right? Because how do I write 192? Yes. So like this, right? So if I'm looking at my positional value chart, so now what octet is this representing for us? The third octet. So if I write 192, I've got this first, this is on, and then everything else is off. So the positional value is 64. Okay? So we're going to put all this together in the next few weeks, but we got to learn all these little bite-sized pieces. Okay, so write this one down, 255, 255, 255, 224. Okay, so everyone, what octet are we in? Fourth. Okay, now you all figure out what the positional value would be for 224, and then just write it down. Don't call it out yet. Two 255, 255, 255, 224. Don't call it out, just write it down. So it's always a good idea to have a positional value chart handy. Okay, if you think you got it, raise your hand. Okay. On the count of 3, let's hear it. 1, 2, 3. 32. That's what I got too. Right? So if we do 255, 255, 255, 224. So we can see that the last network bit falls in our fourth octet. We know how to write 255. That one's nice and easy, right? $224. How do I write it? Yep. 1, 1, 1. And we're dealing with a subnet mask, so everything else is off. All right, so my positional value for this one is what? Right? My positional value for this one is, and then the last one, which is the important one, is 32. Right? And I could have done the same thing. I could have used my, let's see if I can draw a better one. I could use my positional value chart to figure it out. So this positional value chart can represent any octet because what happens? They always repeat, right? So I can just plug this in. There, there, oh, and here's my last one, so it's a 32. Okay? All right, now Paul brought up a good point. So there's a shortcut, an easy way to write a subnet mask. So how do we do it? Yeah, so we just count up the bits. So a shortcut to writing a subnet mask is called slash notation, okay? It's just a shortcut. It's where we just count up the ones. So this is how many ones? Plus, which brings us to, then we do 25, 26, 27. So I could either write this as 255, 255, 255, 224, or I could write slash 27. It's just counting the ones. Because how many bits are in an IPv4 address? 32. So if I know that there's 27 network bits, can I figure out how many host bits there are? How many? 5. Right? Because I could just do the math. I could subtract 27 from 32, or I could count. Okay, everyone got it? That's all there is to a subnet mask. Now again, we're going to add a bunch of stuff to it here in a minute, or next week, which will be here in a minute, right? So the subnet mask combined with the host is what tells us what our network is, and that's what we're moving up to, right? So we write everything out just the same in binary. So it's a good idea to practice, right? When just the 128 is on, it's 128. When the 128 and the 64 is on, it's 192. When the 128, the 64, and the 32 are on, it's 224. When the 128, the 64, the 32, and the 16 are on, it's what? 240, right? And then from there, you just keep adding. All right, so everyone write these out in binary, okay? And I'm going to give you a little shortcut just for what you're doing. I do, and don't ever do this on homework because in Canvas, because it'll mark you wrong. But with this, you could just do it like that, right? Because that means they're all ones. And then here I got to go 1, 1, 1, 1, 1, 1, 1, 0. But when it's just 255, right, just to give yourself a little shortcut. But then write it out in the octet that matters. Write it out in the octet that matters, okay? So you're writing these in binary. Circle the last network bit. Circle the last network bit in each one, okay? Next, determine what the positional value is for that one. So figure out the position value. So you're doing it in binary. You're circling the last network bit. And then you're going to tell me what the positional value is of that network bit. And then lastly, what's the slash notation? How do you write it in the short form? How do you put it in the short form? So a 255.254.0 would be a slash what? Okay, so just write all those down. All right, so this first one, what octet do we have to deal with? Third octet, right here, right? This is my last network bit. What's the positional value? 2. How do I write this in slash notation? Slash 23. Okay, what octet am I in for the second one? I'm in the third again. Okay, here's my last network bit. What's the positional value? 128. How do I write it in slash notation? Slash 17. What octet is my last network bit in? The second. Here's my last network bit. What's the positional value? And what's my slash notation? 12. Right? We just count up the ones. I have 8 here, 9, 10, 11, 12. Everyone got it? Okay. So we can do it in reverse. I already gave you the answer to the top one, so you do 2 and 3. So you're going to tell me what is the decimal equivalent, okay? What's the octet, right? So you're going to convert this to its decimal. So it's going to be what? This one? Everybody. And this one? Okay, now this one. And? So you're going to write that out. Okay, then you're going to tell me what octet, where the last network bit is, and what the positional value is. Because we can reverse engineer it, right? we ready to look at this one? Okay, again, so we know that first octet is going to be what? 255. And the second octet, 255. And then here I've got to add 128 plus 64, which is 192.0. Okay, let's do this one. So what's the first octet? 255. Okay, and then here, we know that when the first 4 are on, that's 240 plus 8 plus 4 is 12. So what have we got? 252. And then 0.0. All right, so let's look at this one. What octet are we in? Right, we're in the third octet. So if I have a 248, once you start getting good at it, your brain will be able to see that the positional value falls where? Right, the positional value is on the 8. Okay, and how do I write this in slash notation? Right? 8 bits are on, another 8 for 16, 17, 18, 19, 20, 21. So this is a slash 21. I'm just counting up network bits. Now, since I know that there's 21 network bits, how many host bits does that leave? Right? 8, 9, 10, 11, 11. So once you know one, you can figure out the other. All right, so for this one, what octet am I in on a 192? Third octet. What's my positional value for a 192? It would be a 64. Now, what would my slash notation be? Right, because I've got 8 ones on plus another 8 is 16, 17, 18. So the short version is a slash 18. Just an easier way to write it. Okay, last one. What octet is this in? It's in the second octet. Now 252, where is my positional value? All right, so I can look right here, and I can see this is the 4th position, right? 1, 2, 4. So it would be 4th positional value. And what's my slash, my abbreviated form? 14. I just count up the network bits. 8, 9, 10, 11, 12, 13, 14. Everyone got it? So if you just take it slow, you won't make any mistakes. Okay, so we talked about the prefix length. Okay. So let's just look at these. Now this is something it's the same as everything we've just been talking about. So the top one, where's the last network bit? What octet? The third one, right? What's the positional value? How about this one? What octet? What's the positional value? This one? What's the positional value? Because the positional values do what in every octet? They repeat, okay? Now, when we see something like this, this is called an octet boundary. Okay, this is called an octet boundary because the network bits are just ending at the end of an octet, right? They're just ending at the end of an octet. So it's just called an octet boundary. A 252 or a 192, that doesn't end at the boundary. It doesn't end at the end of an octet, okay? So we want to think of these as just octet boundaries. What's that? Yes, exactly right. They would all be a boundary. And when we're talking about a subnet mask, right, that is where that term is applicable. Ends on the octet boundary. First octet, second, 4th, right? So we've already talked about our positional values, that they repeat. Okay, so what's the prefix length of that top one? What's the prefix length? Say it louder. 23. A 23, right? Because we counted up the ones. Okay, how about the second one? 17. How about the third one? 12. Okay, how about this one? It's a slash what? Louder. 21, right? Because the first two are on, that's 16. Then we add a few more. How about this one? Louder. 18. How about this one? 14. Right? Got it? How do you write a /9? How do I do it? What is a /9? How would I write it? Yeah. So if I have 9 bits that are on, the first octet is all what? All ones, and then one more one, right? How about a 28? Write it down. Write it out. And a 24. So write those two. And what's special about the last one? It's on the octet boundary. Okay. Everyone got it? See if I missed anything. We already did that. All right. So where the last network bit is, that's called the increment. Okay, that positional value is called the increment, also called the magic number. Okay, so whenever it asks you, well, what's the positional value of the last network bit? That's known as the increment, the subnet increment, or sometimes you'll hear people, what's the positional value of it? Okay, so we're just looking at the subnet mask and we're just determining what octet the last network bit is in. You're just looking at the subnet mask and determining what octet we're landing in. Nice and easy. All right, we're just looking to see where the last network bit is. It's making the brain get used to seeing the octets. Remember, there's 8 in each octet, right? So it goes 8, 16, 24, 32. Can't go too fast. Make mistakes. Okay. That's good. That's what I was expecting. Outstanding. Again, just keeping the brain on it. Give me a second. Let me. So we just did. Determine the octet. So again, I just refresh your screen. You're going to find this one that says, look at the subnet mask and determine the octet. Enter your score or the total number you got right. Okay, enter your score. It's under week 2 class activities. You'll either see it on your to-do list, the calendar, or you can go to modules. It's the Kahoot that says subnet mask or octets. Look at the subnet mask, determine the octet. Determine the octet. Just enter your score or the total number you got right. Either one is fine with me. Okay, now this one, we're looking for the increment, wherever the last network bit is. So you might want to have a positional value chart handy, right? Because you're going to be looking at the subnet mask and determining what the positional value is of the last network bit is, right? So 255.255.0.0, what's the positional value? 1. 255.255.0.0. It's 1, right? You got to think about where's the last network bit. So it's going to give you a subnet mask, and it wants to know what the increment is, which is where the last network bit is, okay? Sometimes that's called the magic number, the increment, the positional value bit. Okay, so you're going to be looking at the subnet mask and determining where the positional value of the last network bit. Subnetwork increment. So we have to look in the 4th octet, and we're figuring out what the increment is, right? So you got to plug that 252 in, right? What gets you up to the 252, and then where's the last bit? That's why you got to learn these binaries, right? 128, 192, 224, 240, 248, 252, 254. Oh, don't worry about it. Just keep what you get right. So 248, right? We know the simple plan, 1, 1, 1, 1, and then the 8. So we've got a positional value of 8. Thanks for participating. Yep, apparently there's no points. That's all right. All right, so it's not as,
So like I know 252 as a position of value for, I'm a network IT guy, I'm sat behind a terminal, when do I use it?
I'm gonna teach you that starting next week or the week after. We'll put it all together. You have to know how to build networks and what the next network would be, and you use the increment for that. So if I have a 192.168.0.0/24, and I need another network, what would I increment by? So my next network would be 192.168.1.0/24. My next network would be 192.168.2.0/24. If I had a 26, what would my next network increment by? 64. Okay, so again, we're gonna pull all these pieces together, but you gotta learn these little things, because if I just say, okay, we're gonna do VLSM and network addressing, I'd have about 8 withdrawals. Yeah, but we're gonna learn. And we'll do it we'll do it all the time, okay? What did we just do? So I'm gonna turn that. Why don't I see that one here? Let me make one. We just did the subnet increment, right? Subnet increment. Yeah, just put in the number you got right, or close to it if you weren't counting, or if it didn't tell you. Okay, if you refresh your screen, it should be in there. Again, most of these are just for participation, unless you're really slacking and not doing anything. If you refresh it, you should see it'll say increment, the one with the increment. Look at the subnet mask increment. All right, let's take a 5-minute break. It's 4:29. Let's come back at 4:36. Okay, and we'll wrap up talking about layer 1. we're gonna talk about all that. Mm-hmm. We haven't set up a time yet, but as soon as we do, you'll be able to do that. I don't think it has a date on it, does it?
I think it's a Saturday.
Oh, oh, we don't have it set up. All right, so, huh? I don't use a power, I use hand, just a hand tool. I think I have a power one, but I've always just done them by hand. Is that a real thing? And it will terminate correctly? If you're making a, oh, for twisting it, okay. I got you. Yeah. And they work? Oh, okay, that's lucky. All right, so we're gonna finish by talking about some things on the physical layer. To some extent, the physical layer we kind of been dealing with most of our lives, or from the time you started working with computers, or even using wireless devices because you're connecting to wireless or you're plugging a cable in. So all of that's layer one. You may not have known it, right? Plugging in an Ethernet cable, plugging it into your NIC, putting in a wireless adapter, all of that is functioning at layer one. And then what we want to get good at understanding is the difference between a crossover and straight through, and when to use it, how to tell the difference. And somebody had a good question on the survey, I don't remember who it was, or not really a question, but a notice, right? That there's some idea that you don't need to know anymore the difference between a crossover and a straight through, but actually you do. And the reason, so a crossover and a straight through cable each has different functions. So if you look over there, back in our router room, we've got straight throughs, which are blue. We have crossovers, which are yellow. So when would I use a straight through cable? Oscar? Right, if I'm connecting two different types of devices. And when would I use a crossover cable? When I'm connecting the same. Yeah, exactly, switch to switch, okay? And the reason is because their brains are a little different. The NIC card inside each device, the way that they format information is slightly different. Now, there's this new really cool thing called auto MDIX, and most all computers do this. Most all devices do this. And auto MDIX is when it will just auto negotiate. It can tell, or it doesn't care whether you plug a straight through in or a crossover. It'll just make it function the right way, because the NIC cards have gotten so smart that we don't have to be as smart. So here's the rub about that, though. Not all of them have the feature, and sometimes it gets turned off, okay? Now, I'm not exactly sure, but I can tell you Walmart turns it off. ASU turns it off. Okay, they turn off auto MDIX. They want their networks wired and cabled correctly. They don't want to rely on auto MDIX, okay? Yes? I think with the iOS version 12, which isn't that long ago, 8 years ago. And it is not uncommon for companies to keep a device for 20, 30 years. It's like a baby. If it's not crying, don't fix it, right? Don't give it a bottle. And so you're going to find in the field that a lot of people use older equipment. If it works, why spend the money? You know, if this is meeting my needs, why spend the money? Hi. So again, what we want to do and what I want you to get in the habit of is always using the right cables, okay? Always using the right cables. And so we're using a crossover to connect, again, what kind of devices? The same. And straight throughs. And what makes it different or the same? Yeah, and what type of device it is and how their brains think. Okay, so let's break that down a little bit further. So if I connect a switch to a switch, what kind of cable will I use? Crossover, because their brains are the same, right? Their NIC cards and where the Ethernet plugs into, they're going to encode information and decode information the same way. If I connect a router to a router, crossover, okay, tricky question. A computer to a router. Why? Yeah, they have a similar brain. Okay, so the way that the NIC card in your computer works, and the way that the card in the router works, and the way they encode and decode and process information is the same. So a router and a computer think they're similar. So you would actually use a crossover cable when you're connecting a router to a computer. Okay? What about a router to a switch? Straight through. And what about a switch to a computer? Straight through, because they have different brains. A switch is actually a fairly simplified product, okay? Switches are designed to move frames, and frames function at what layer of the OSI model? The data link layer. And the data link layer is taking care of what as it relates, like if we're thinking in terms of networks, what types of networks is the data link layer taking care of? Local, right? A local area network. So it processes information different. It doesn't have to be as broad. It doesn't have to be as smart as a router does. It doesn't have to be as smart and process as much information as a computer does, okay? So that's how we do that. Now, we've got STP and UTP. So what is the difference between STP and UTP? Blake. I'm sorry, Darren. Blake. Yeah. And so one is really stiff, right? And it offers a little extra protection from what two things? Crosstalk, EMI, and RFI, which is what gives us crosstalk. Now, honestly, I do not see shielded twisted pair very often, which I don't really understand because it is a superior product, but it's really difficult to work with. So it's super stiff. It's harder to peel. It's not, you're more likely to cut yourself when you're working with it. So it's just, I can't even find any to show as a sample. Like I've called friends that I have that, work at CenturyLink, and they're like, we don't use that stuff. We don't use that crap, So Paul asked a really good question. So if you notice back there, we happen to color coordinate our stuff. We use yellow cables for crossovers, and we use blue cables for straight throughs. And why do we do that? Just because. There's no guarantee that where you go will have any type of color coordination at all. As a matter of fact, it's not uncommon that you'll see all different colors. Okay, so what I want you to do, again, in our lab, we make it easy. If you have a yellow, you have a crossover. If you have a blue, you have a straight through. Okay.
Is that pretty consistent like with Cisco stuff? Or
No,
is it,
it's just what we do. I like purple and pink. In my office, I have pink, and in here, I use purple because I like it. Right? That's it. There's no other. It's just the way I get my girl on when it comes to computers. And there is no, there's no rhyme or reason. Now, wherever you work will typically have a standard, right? But that's it. What makes it a crossover or a straight through? How you terminate the cable at the end. Okay, so what are the two termination types? What are the standards? T568A and T568B. B. So what does the A begin with? It's green, yeah. So the A's begin with green, right? Always grow oranges by berms. All right, so here's what I'm going to do. And you can look at these in a couple different ways. I'm going to just pass these around. So everyone just grab one. So take one and pass it. And we're going to see if we can tell what they are. Some of them are really easy to tell, and some of them are not so easy. And another thing is sometimes it's hard to tell the difference between brown and orange, okay? And they're both on the ends. So again, and you can take more than one, you know, so go ahead and pass them around. Just, yep, keep passing. Okay. When in doubt, look. You know, when in doubt, look. Now, with this purple one, it's nice and easy to tell from the flat side. Right? But it's not always that way. Sometimes it's easier to tell from the clip side. You just have to look. But what you're trying to determine is, does it begin with an orange or a green? Okay, so you're just looking, and again, you might have to flip it around. Now, I usually read it from left to right. So like I'm looking at this purple one on the flat side from left to right, and it starts with orange. So since this one starts with orange, is this a T568A or a B? It's a B. It's a B. Okay, now, when I look at the other side, so now I'm going to look at the other side because I'm trying to figure out if this is a crossover or a straight through. Trying to figure out if it's a crossover or a straight through. So what would make it a straight through? Well, what would the other end be? So if I've got a B, because it starts with an orange, it would be another B because the wires run straight through. That's how I remember it. They run straight through. So I have two oranges, orange and an orange that starts. So I have a T568B straight through. Okay. What have you got? You got a straight through. So what have you got, Aiden?
Straight through.
You have a straight through? And is it an A straight through or a B straight through? It's a B, so it starts with an orange. Okay. Because it could be either. I could have a T568A, and that would just be a 568A straight through. So it doesn't matter. If it's an A or a B straight through, it's still a straight through. And these devices don't care. These devices don't care, okay? Now, what about, who has a yellow one? What have you got, Darren?
So I have the T568A, and then the other one is a T568B.
B. Okay, so you have a crossover. So a crossover just means that they're crossing over the colors. So one end is going to start with green, and the other end is going to start with an orange. And the colors that get flip-flopped is always the orange and green. Okay, it's always the orange and green. Okay?
So, wouldn't that mean that because of you swatching the pins around, when you have a crossover cable, it could be the wrong way? Like if you plug it in, it's the right way if you flip it that way.
Nope. All the work is done within the cable. So the device doesn't care. It cares if it's a crossover or a straight through, but it doesn't care what end it's receiving because here, let me see if I can find the little diagram. As long as it gets one receive end, it's fine.
I guess I'm just confused as to why they would do this. Why wouldn't you just make everything straight through cables?
Okay, well that's why MDIX was invented, auto MDIX was invented. The reason is because of the way things get encoded. the way, remember what encoding means? The way the bits are put down onto the media and removed off the media? That process is done differently depending upon whether you have a switch, a router, a computer, a server. And so they have to build the NIC card in order to be able to do that. One process is easier than the other process. So again, in legacy days, and really, again, please do not get used to, oh, I can use any cable I want. Like that'll, you'll go into a network, you'll plug in some cables, and you'll be like, why isn't this working? Why isn't this working? It could be as simple as you needed a crossover cable instead of a straight through cable. It's just a legacy technology. I don't have an exact explanation, other than, again, the way that bits are encoded and decoded. Oscar, did you have something to add?
So I'm just curious that why didn't something as either yes or no isn't phased out? Like nobody goes to Best Buy. Like I'm actually looking for a straight through, not a crossover. It's all the same Cat5 cable.
When you buy cables, it'll say whether it's a crossover or a straight through. It will. It'll tell you what the standard is, 568A or 568B.
I have a bunch of different cables at home, but they're all using that protocol, and they're all.
Everything's using auto MDIX, unless I turn it off. Or I have legacy equipment that doesn't have the ability to auto detect. Legacy equipment will not have the ability to auto detect. It's dependent upon you as the network administrator to plug in the right cable so that the encoding and decoding process can work properly. Okay?
So you're just gonna stay with like networks forever?
I think it's gonna be for a while. As long as, I think as long as we're using Ethernet, yeah. And again, there are companies that turn it off. So we just, and we will do an exercise in this class, and that might be the problem. So when you have something that doesn't work and you're supposed to fix it, you might want to think about what the cable is, because I might have turned it off. I might have turned off auto MDIX. In the past, okay, I think it was version 12 when it converted over, but you still had to turn it, you had to turn auto MDIX on. It used to be where it was you had the capability, but you had to turn it on. Now that's the default, and you have to turn it off. So do I think it will phase out? I don't know. Why do we still use IPv4? I don't know why. So I don't know how fast it will phase out. I don't really know how fast it will phase out. So something else to keep in mind, that it's just a good idea to remember, is that the way that these cables cancel out EMI and RFI is with the twisting, okay? So these are all twisted, and they're twisted at different lengths. You can kind of see here, the browns are a little bit longer, the orange is the longest, the blue is the smallest, and all that does, that twisting just prevents EMI and RFI. Again, I'm not sure about all the science behind that, but it has something to do with the way the electrons are dispersed. So, let's see, let me find our 568As. We will have a lab where we'll do an extra credit. We used to build cables in the class, but honestly, it just takes too much time for us to do it in class anymore to get a really good cable. But we do offer it as an extra credit lab so you can practice terminating. Why do you think you need to know how to make a cable? Tony?
You're out in the field in the middle of nowhere, you've got a bunch of wires, you've got the connecting boards.
Yeah, exactly why. You might be in a position where one end is busted, you don't have another cable, you can just cut that end off, right? You may have a crossover and you need a straight through, cut the end off and make it. I personally like to have cables that are about the right length with maybe 2 feet of extra loop. I don't want to have 20 feet of extra loop. So I have a tendency to make my own cables because I'm, picky like that. Oscar?
My time in IT, there is no perfect length cable for everything.
Well, except a perfect length is one that's not too long.
Yeah, but you'll have like the common 3, 6, 9,
Yeah.
and then after that it's like
Yeah. So, I mean, it seems like I'm always having to make my own cable for some reason. Right now at home, a clip came off of one of my ends, and so I was like, and I hate that because it keeps falling out of the computer, I'm like, ah! So tonight I'm gonna take some equipment home, and I make one, just clip the end of it and make one. So it's just a good skill to have. Oh my gosh, I forgot. So I have a student who had a job interview like a year ago, and they asked him to make a cable. And I was like, you are kidding me. And the reason I was just surprised is it just never had a student be asked that before, but we don't do it in class anymore. The A+ class, they still learn how to build cables. And again, we just don't have time to do it. And so that's why we do it as extra credit. And he had never built one. They helped him. They're like, oh, well, we'll do it with you. And so I was like, well, that was nice of them. And he did get the job, but and they asked him questions about the like when do you use a crossover? When do you use a straight through? What is the standards? And, again, we go over all that. So thankfully he had all of those answers, but we had never built one in class. And I don't he didn't do it as extra credit because he told me I had never done one. And I told them, I've never made a cable. And so I was just like, and that was just like a year ago. So it happens. And the reason is because that particular company, they set up LAN networks, and their technicians have to build cables all the time. They have to build cables all the time. And so, it's something that happens. Let's see. Right, so here again is here's our A starting with the green. We flip the orange, the blue. So the blue is more for like power over Ethernet, and then the browns are for like our gig service. So those don't even necessarily get used depending upon what the device is and what your application is. Let me see, there we go. So it has to do with the sender and the receiver. Paul, back to your question, like why does it even matter? And again, I don't know all the science behind it, but it has to do with the way that these are split and the sending and the receiving within the NIC card. And whether, it has to know whether it's getting the send or the receive. Now, switches work in full duplex now. So again, that's another reason why this isn't as important, right? But in the old days, all we had was half duplex. You could only send or receive. You couldn't send and receive, right? So the fact that we now have full duplex is what allows us to have auto MDIX. So because the devices have the ability to do that. And again, this is if I'm doing, the blue is for power over Ethernet, right? And then these are for my higher speeds, okay? So let's see, just a quick little way that I remember it. I mean, I mostly just know them now, but the A, always grow oranges by berms, green, orange, blue, brown. The colors. And you could probably make one up that's better for you to remember, Grow is for green, orange is for orange, by blue, brown. All right, so what time is it? Okay, so we're gonna end, so front load, okay, front load. Next week, we will go over fiber optic, because we didn't have a chance to talk about that today. And we're gonna do a lab, a short lab on Monday, and we're gonna do a longer lab on Wednesday, which is 255. So you have to have those commands. Module 2 and 5 is what we're doing. Neither of them are very long, okay? And 5 is everything we just did, hexadecimal, binary. But module 2 is the beginning of commands, okay? Get the commands, write them down, put them in a file, come ready to talk about them so that we can use them when we're doing it. And then I'm going to teach everybody how to connect our computers up to the equipment back there, and we'll go over all that, okay? Front load, if you finish 2 and 5, you need to start on 6, okay? 6, 7, and 9 are big modules, and there's a lot of stuff. So if you get through 2 and 5 and you've taken your notes and it seems like, oh, this is good, don't rest. Don't rest, okay? The class is just gonna come barreling on you. Take advantage of the fact that next week isn't really a bad week, right? Those chapters aren't too bad, so take advantage of it and get into module 6, okay? If you could all coil up your cables and just move them towards the center. There's one under you, Aiden. Blake, did you get all your Cahoots entered? Okay, because earlier there was one missing. You probably entered it by then. I just was already in there looking. Yeah. I mean, I know you were here, so. Thank you. Thank you. Thank you. Thank you. Perfect. See you Monday. Do a lot of homework, everybody. You got it. Bye. Do you go by Natalie?
Yes.
Okay.
It's called me, that's why it's easier.
Yeah, whatever you prefer. I noticed that on one of your things, so I was like,
Oh,
okay,
yeah.
okay, good.
See you at
Bye-bye.